introduction. So the term beam refers to a slender bar that carries transverse loading. So that is the applied force are perpendicular to the bar. Yan. So for example, we have a beam. Yan. And then sabi do dito, it carries a transverse load. So dito mga transverse load natin. And then so, ang perpendicular daw nun is nag-a-apply ang force natin. Could be a concentrated force or a uniformly distributed loads. Yan. And then in a beam, the internal force system consists of a shear force and a bending moment acting on the cross section of the bar. So I hope last mechanics of deformable bodies is na-discuss yung mga what we call the bending stress. That's the 6m over b squared. Yan. And then we also have the shear stress. So naalala pa ba yun, class? Sa inyong mechanics of deformable bodies. Yan. Well, actually, yun nga, kailangan alam nyo rin yun as we're going to encounter those stresses pa rin. Yeah. So we have the what we call the bending stress. Yan. Which is kapag rectangular is 6m over b squared. So naalala niyo po ba yung class? And then kapag hinahanap naman natin is the transverse stress or the horizontal shearing stress. That's the tau is equals to 3v over 2a. Okay. So, naalala niyo pa ba yung class? So, mamaya, magkakaroon tayo ng ganong example problems din, no? So, the internal forces give rise to two kinds of stresses on the transverse section of a beam. So, we have the normal stress that is caused by the bending moment and shear stress due to shear force. Okay. So knowing the distribution of a shear force and the bending moment in a beam is essential for the computation of stresses and deformation, which will be investigated in subsequent chapters. Yeah. So last week class na-discuss na rin natin itong mga typical supports, mga type of supports na we encounter here in this subject. So we the supports and loadings that we have. The first one, we have the simply supported beam. Yeah, so we define it as statically determinate beam class, no? Dahil we could solve its reactions or forces just using equilibrium equation. And then we also have the cantilever beam and overhanging beam. So there are three types of beam that is statically determinate. So the simply supported, the cantilever beam, and the overhanging beam. So we already defined what is a concentrated load, a distributed load. So ang unit ng distributed load is it could be sometimes meron siyang Newton per meter or kilonewton per meter. So yung meter is the whole span ng ating distributed load. So that's what we call the W, intensity W. So it could be pounds per feet. So it may vary with distance along the beam. Then we also have the weight of the beam. So kindly take note if kung nasa given na yung weight ng beam, so we have to compute its weight. So hindi pa kasama doon class yung mga distributed loads or mga constituted. Then we also have the statically indeterminate. So usually class, um, we define some fixed end and a roller support at the end as statically indeterminate. And then, of course, kapag both ends naman, yan, we define it as statically determined. So, the prop, cantilever beam, and the fixed or restrained beam. So, in shear and moment equation and shear moment diagram, so the determination of the internal force system acting at a given section of a beam. Yan. So, at a given section of the beam, we could identify class yung mga internal forces natin. Like the shear, the moment, yan. So the goal of the beam analysis is to determine the shear force and the bending moment at every cross-section of the beam. So for example, yan, there's a certain distance which in kailangan natin ma-determine yung shear force and then bending moment. So we have to first, yun nga, we should first draw the shear and moment diagram para mas mabilis natin makuha kung ano yung mga shear and moment forces natin and moment. So to derive the expression for shear and moment in terms of the distance x measured along the beam. So by plotting these expressions to scale, obtain the shear and moment diagrams for the beam. So later on namaya, class may sample problems about shear and moment. So the shear force and bending moment diagrams are convenient visual references to the internal forces in a beam. Yeah. So we could identify there the maximum values of our shear and then moment. So that's the reason why we compute the maximum shear and moment. So of course, we identify allowable stress and then also identify yung pinaka um, yun. So meron tayong tinatawag na allowable stress and then the ano po ba yung isa? Tas yung failure, maximum failure stress. Yeah. So na-discuss natin yun sa ating mechanics of deformable bodies din, which is we compute the safety factor ng ating structure as Fs, which is the safe factor, is equals to could be the failure stress over the allowable stress ng ating beam. So times 100%. So usually class, yan, unitless ang safety factor. And then here's the procedure for determining the shear force and the bending moment diagrams. So compute the support reaction from the free body diagram. So basically class, sinisimulan natin siya by computing the support reactions. So kapag simply supported siya, so kailangan natin makompute yung pinaka-left and right reactions. So we divide the beam into segments so that the loading within each segment is continuous. So that's the endpoints of the segment are discontinuous of loading, including concentrated loads and couples. Then perform the following steps for each segment of the beam. So introduce an imaginary cutting plane within the segment located at distance x from the left end of the beam that cuts the beam into two parts. Yan. So once we cut the section, yun nga, we separate yung left and the right section ng ating beam. And then we going to draw our free body diagram for the part of the beam. So that's the time we're going to analyze yung mga directions ng ating mga shear and moment. So at this cut section, show V and shear and moment acting in their positive direction. So, ganun naman class kapag once na kinumpute natin yung shear and then ang lumabas is negative, it means wrong assumptions tayo. So, at the same with our moments. And then, we're going to determine the expressions for the shear and moment from the equilibrium equation, obtaining from the free body diagram. So, these expressions, which are usually function of x, so are the shear force and the bending moment equations for this. Then we're going to plot the expression for V and M for the segment. So we could identify, of course, the our shear diagram from the loadings na meron tayo sa beam. Yan. Then we could convert ang ating shear diagram into moment diagram. So the bending moment and shear force diagrams of the beam are composites of V and shear and moment diagrams of the segments. So these diagrams are usually discontinuous or have discontinuous slope. So at the endpoints of the segment due to discontinuities in load. So we'll be having now an example. Sample problem 4.1. Yeah. So we have here a simply supported beam. Yeah. So can you see this the figure? So let's analyze first figure. So we have reaction at A and reaction at B. Then meron tayong segments na A, B, C, and D. Then meron din tayong given na two concentrated loads downward direction 14 kilonewton and 28 kilonewton with a distance of 2 meters, 3 meters, and 2 meters. So let's read first yung ating mga given. Okay? Okay, so let's start with sample problem 4.1. So the simply supported beam in the figure carries two concentrated loads. So first one, we derive the expression for the shear force and the bending moment for each segment of the beam. Then we're going to sketch the shear force and the bending moment diagrams. And then may note tayo dito na we're going to neglect the weight of the beam. So it means we're not going to include the weight of the beam. So sometimes it is in kilogram or in pounds yung ating weight ng mga beams. So since dito, sinabi na we're going to neglect the beam, the weight of the beam. So note that the support reactions at A and D have been computed and are shown in figure. So, yun natin kailangan na mag-compute ng ating reactions na given na tayong mga reactions. So, solution is part 1. The determination of the expressions for V and M for each of the three beam segments. So, meron tayong three beam segments. We have the A and B, B, C, and C, D. So for this segment AB, so segment AB, as we could determine that 0 is less than x is less than 2 meters. Yan. So we identified na yung x natin na dinenote is along dun sa gitna ng 2 meters. So how do we solve for our shear force? So by using the summation of forces, y is equals to 0. So upward is positive, then downward is negative. Yan. So, tignan muna natin yung ating gagawing free body diagram. So, let's example, we cut a section dun sa ating segment AB, yan, in a particular X from A to B. So, this is our X. Yan. And then, given tayo ng ating reaction force at A, which is 18 kilonewton upward. So, we're going to determine the shear dun sa ating segment AB. So, we could easily identify our direction ng shear, which is downward class. So, it could remain in equilibrium, no? Kasi meron tayong upward na 18 kilonewton. So, by summation of forces, y is equals to 0, then we have 18 upward minus our v is equal to 0. That's why we have a shear force of v is equals to positive 18 kilonewton for this segment E. Then, of course, syempre, once we cut a section, yan, in a beam, so kapag hindi naman siya given na pin connected or hinge connected, automatically, class, magkakaroon ka ng three reactions. But since dito, class, is simply supported naman siya, and then lahat ng mga ating mga loads or mga forces is upward and downward lang, wala tayong horizontal forces, then we neglect it na yung ating horizontal force. Kasi mag-equal to 0. So automatically, class, kapag nag-cut tayo ng section sa ating beam, so magkakaroon tayo ng three reaction forces. We have the X and Y, and then our moment. So again, class, kaya wala ditong horizontal dito sa ating figure na kinat sa left side. Ating left side is, yun nga, mag-equal to 0 siya dahil wala naman tayong ibang forces na nag-act horizontal. So by summation of moment at point E, yan, is equals to 0. So counterclockwise is positive and clockwise is negative. So we have negative 18x plus our moment is equals to 0. So our M is equals to positive 18x kilonewton. M. So, naintindihan, class? How do we solve for our shear and moment? So, right now, yun, class, wala pa tayong, wala pa tayong definition ng ating X natin na to. So, the reason why, class, na nag-identify tayo ng ating X, yan, kasi kung kinukuha natin yung pinaka nearest distance natin dun sa pinaka segment natin na 2 meters. And then next, we identified our segment AB dun naman sa right side natin, which is sa gitna nung ating first 2 meters hanggang dun sa dulo ng ating point B. That's why we have here 2 is less than X is less than 5 meters. So again, class, we will analyze this second figure natin sa right. Yan, having a 14 kilonewton and 28 kilonewton na mga concentrated load. And then, yun, as you could see, class, no? Yun, rule din natin yun sa mga member type na mga structure natin. So once we analyze the second section, and yung mga inanalyze natin na shear and moment forces is mag-iiba ng direction. So, as you could see, class, sa left section, downward ang ating shear, then dito naman is upward. And then yung ating moment is counterclockwise sa left section, then yung dun sa right is naging ano na siya, clockwise. So, para maging equilibrium yung ating beam. So, let's start now. No? So, using summation of our forces, 2y is equals to 0, we have here 18. So we have here 18 minus 14 minus 28 minus v is equal to 0. Yeah. So 18 minus 14 minus 28. So we will be having a negative 24 kilonewton. Ay, iba tayo dito. Dito pala tayo, segment AB. So we have 18 minus 14 minus v is equals to 0. So V is equals to 18 minus 14 is equals to 4 kilonewton. And then for the summation of moment at point E, yan. So we have negative 18x plus 14 times x minus 2 plus moment is equals to 0. So we know, class, na from A to B, so that's 2 meters. And then we define our x, yun, near dun sa ating segments A and B. Okay. And then next is summation of moment E is equals to 0. So we have negative 18x plus 14. Then yun nga, ang kailangan natin doon na part is 2 minus x. X minus 2 pala. X minus 2 plus our moment is equals to 0. Sorry, bulaging calculator. And then m is equals to positive 18x minus 14. Quantity x minus 2 is equals to magiging 14x plus 28 kilo newton. Ayan. So, nasundan, class? So we will now proceed sa next na segment natin, which is segment CD, which is 5 meters is less than X and less than 7 meters. So yung gitnang. Yan. So from our free body diagram, plus ayun, ito. So ito yung ating X, and then ito yung ating 2 meters. That's why we have X minus 2. So ito yung hinahanap natin, X minus. Okay, so let's proceed now to the segment number CD naman. Okay. So we're going to analyze the segment CD, which is 5 meters is less than X is less than 7 meters. Okay. So we're going to use summation of forces. Y is equal to 0. So we have 18 minus 14 minus 28 minus V is equals to 0. So ang ating V sa left side portion is negative 24 kilograms. So it means parang sinasabi dito na wrong tayo ng assumption ng ating shear dahil naging negative. But don't worry class, yan. So kaya natin ina-identify din yung shear natin sa moment sa both section para is maging equilibrium yung ating beam. So summation of moment G is equals to 0. So we have negative 18x. So we have this x, then negative 14 times our x minus 2. Yan. So as you could see, ito yung x minus 2 natin. So dun tayo sa pinakagitna ng ating segment CD. So we define it as our x mula dun sa point A to gitna ng CD. Then plus our 2x times x minus 5. Yan. Still denote our x from A papunta dun sa ating gitnang CD plus our moment is equals to 0. So m is equals to 18x minus 14 times x minus 2 minus quantity x minus 5 is equals to negative 24x plus 168 kilonewton meter. And then for our second part, yan, so we're going to determine na syempre yung ating mga maximum shear force and maximum moment ng ating diagram. Okay, so this is our figure. Ayan. So here's our figure. So, anong una natin gagawin, class? Okay, so the V diagram reveals that the largest shear force is in the beam negative 24 kilonewton. Yeah. So how do we analyze V diagram? Yan. So first, magsisimula tayo syempre from left to right. So, ma-determine natin ang ating shear diagram dun sa ating mga loadings. So, okay. So we have here a concentrated load na pataas na 18 kilonewton. So that's why we have 18 kilonewton. So can you type it on your calculator? And then, yun. So magre-retain lang yung 18 kilonewton. And then until such time, meron tayong concentrated load na 40 kilonewton. So 18 minus 14 natin is equals to 4. So that's why we have here ay 4 kilonewton. And then, meron tayong ulit na loading na 28 kilonewton. So, minus 28 kilonewton is magiging negative 24 kilonewton. Plus, ating reaction force na 24 kilonewton plus 24, so magiging equals to 0. So, normally, class, kapag mga determinate structure, naging equal to 0 talaga siya. Both shear and moment. Kapag simply supported, automatically yon class na nagsi-zero siya. So that's why yan nga as we could analyze yung ating shear diagram, ano yung pinakamalaking ano dito, shear class. In the negative 24 kilonewton. Okay? And then for our moment diagram, reveals that the maximum bending moment is 48 kilonewton meter. The 28 kilonewton load at C. So doon ang maximum mo. So yan class. So let's draw our moment diagram naman. So from our shear, so we could draw ang ating moment diagram by computing its area. Okay, so natatandaan pa ba, class? Okay. So, yan. So, let's compute muna yung area from A to D. So, we have a rectangle with a dimension of 2 meters times 18. So, 18 times 2 is positive 38. So, please observe class yung mga signage natin. Kung positive siya or negative. So, we have 36. And then, i-add lang natin, class, yung ating next figure from B to C plus 18 times 4 ay 18 times 3 pala. So, 18 times, hindi, 4 times 3. So, kinocompute natin yung area bounded. So, that's 48. And then, as you could see, class, nasa baba siya ng ating x. So, meron tayong, mag-minus tayo ng area, which is negative 24 times 2. That is equals to 0. So, as you can see, class, yun nga, nag-0 siya. Then, remember, class, yung mga units. Kapag, syempre, kapag moment, kilonewton per meter, or depends kapag ano yung loading. So, as we could observe here, class, ang pinaka-highest na max or maximum moment natin is 48 kilonewton, which is in the point C na meron 28 kilonewton. And then, as we could observe, class, no, as a time na mag-zero ang shear, nandun ang pinaka-maximum moment. So, as you could see, class, dito sa x nung ating shear, no? So, at the time na dun siya nag-equals to 0, dun ang ating maximum. So, there is discontinuity in the slope of moment diagram at each concentrated. So, note that each concentrated force that V diagram jumps by an amount equal to the force. So, next problem natin, sample problem 4.1. So, can you read this one first? So, the simply supported beam in figure A is loaded by the clockwise couple. So we have here a couple at B. And then we're going to derive the shear and bending moment equations. And then we're going to draw the shear force and the bending moment diagram. So again, class, we're going to neglect the weight of the beam natin. Yan. And then the support reactions A and C have been computed. Their values are shown in the figure. Okay, so the support reactions A and C have been computed and their values are shown in the figure. So, yeah. So as we could observe, plus, no, lahat siya is naka-variable. So we have a length of L, then meron din tayong reaction force na CO over L, and then RC na CO over L din. And then, yun, ang distance nung from A to B is 3 over 4 L. Then, yun, may segment AB and BC tayo. Okay, so this is our figure. So for our first part, so due to the presence of the couple, we must analyze segment AB and BC separately. So segment AB, so from 0 is less than x is less than 3L over 4. So this is our x. And then we also have the reaction forces as we cut the sections. So we have a shear and moment. Yeah, so by summation of forces, y is equals to 0. You have a negative CO over L minus V is equals to 0. So ang shear natin is negative CO over L. And then by summation of moment, V is equals to 0. Counterclockwise is positive. So we have a CO over L times X. Yan. So ang point natin is D plus, remember that, plus our F na counterclockwise kaya is equals to 0. Then ang ating M is equals to negative CO over L. So nakuha na natin ang mga expressions ng ating shear and moment sa segment AB. The next naman is yung ating segment BC. So from 3L over 4, ito, something like at the point B, papunta dun sa ating point C. Dun sa gitna. Yan. Yun naman yung ating X. Yan. So from our figure class, yung ating X is from our point A to the segment BC. So by summation of moment, y is equals to 0. So we have a negative CO over L. And then negative V is equals to minus V is equals to 0. That's why we have a V is equals to negative CO over L. And by summation of moment E, at point E, again, class, this is our E is equals to 0. So we have CO over L, X minus CO plus M is equals to 0. Then ang ating M is equals to negative CO over L times X plus CO. It's our expression for the segment BC. Then for our second part is we're going to draw our shear and moment diagram para ma-determine natin yung mga maximum shear and moment. Yeah, okay. So for the part 2, from the V diagram, can you read? From the V diagram, the shear force is the same for all cross-section of the beam. The M diagram shows jump of magnitude CO at point of application of the couple. So first up, we have a downward CO over L. So kahit na hindi natin alam yung value, we know that there is a downward shear. Then since class, wala tayong any other concentrated loads or uniformly distributed loads. Yan. We go straight to the end, and then we add our reaction, which is CO over L. Kaya magiging equals to 0. Magiging 0 ating shear. Then for our moment, yan. So for our moment, we're going to compute the area ng ating shear. So we have here yun. Lahat sila, di ba class, nasa baba ng x. So since nasa baba siya ng x, so magiging negative. So negative 3 over 4 times L times CO over L. So meron tayo negative 3.4 CO. And then, since meron tayong couple, so we consider couple as moment pa rin. They have the same unit. It could be kilonewton meter or newton meter. So we added it. So plus CO. So negative 3 over 4 plus 1. So we have 1/4 CO. And then yun. So we have 1/4 plus our 1/4 L times yung CO over. Kaya mag-equals to 0 yung ating. So that's it for our second problem situation. Okay. So we'll proceed for another sample problems natin. Okay. So, okay. So any question, class, so far? Okay. So this is our second sample problem. So kita na, class. So I'd like to emphasize first, class, yung ating shear and moment diagram. So for us to easily identify, class, kung ano yung magiging shape niya. So always remember this theory of emoticons. So using our shear and moment diagram, we need our V is equal to the summation of our forces sa left is equals to the summation of forces natin sa right. And then our moment is equals to the summation of our moment sa left, and is equals to the summation of moment natin sa right. So kita, class. Okay. So this is the theory of emoticons. So for example, we have a simply supported, no, not simply supported. For example, we have a uniform supported load, itong rectangle na to. And then for our shear, yan. So for our shear, ito yung ating shear, class, di ba? Then ito yung ating N. So kapag ganyan, meron tayong distributed loads dito. So this distributed loads, uniform at a certain span. Meron tayo a certain span. So automatically, ganito ang magiging figure. So para siyang straight na ano na line. Diagonal line. Yan. And then yung ating moment is magkakaroon ka ng pa-curve. Yan. Na pataas. So para mas madali nating ma-determine siya, syempre, yan nga, meron tayong load na pababa. Yan. So it could easily put us down. So as we could see, no, uniform lang yung ating load. So parang we identify it as ano lang, parang neutral lang. That's why yung figure ng ating shear is naka-straight na diagonal. So this straight diagonal tapos para siyang naka-smiling face. Parang neutral face lang. Then from our shear, as we could observe, di ba class, yung ating line is pababa. Siyempre, when we experience down moments is we usually meron tayong sad moments. So kaya ang ating M is para siyang naka-sad face na emoticons. So, again class, yun nga, from our shear yan, di ba? So pababa siya, kaya meron tayong sad face na diagram. Sure. Then, let's go with our next figure, which is yung triangular load. So we define it as our M, then our V and M. So we have here, pataas. Yan. So pataas yung ating rectangular from point A. Let's say this is our point A. And then this is our point B. So syempre, kayo as a civil engineering student, as you go along, take another level, yan, yung V natin is para tayong nahihirapan. That's why meron tayong sad face dito sa ating V. So, take note that. And then, yung ating moment, syempre, kapag malungkot ka, dito sa share, mas malulungkot ka pa dito. So, please take note to. Marami nagkakamali din kasi talaga sa kung pa-concave upward ba siya o concave onward. Then, for our next figure, yan, yung triangular load natin is nag-start naman siya sa pataas. Yan. Then pababa. Yan. So that's the time na parang nakakahinga ka na or nakagraduate ka na parang. Yan. So that's why masaya ka na. So, parang kasing na-pick mo ni yung pinaka-highest point, kaya pababa na, kaya meron ka ng smiling face na figure for the shear. Then, for our moment, yan. So, from masaya, yun, may instances na magkakaroon ka din ng lungkot. Dahil yung figure natin sa shear is pababa. Down. Kaya sad mo. And then for our last figure, yan. So we have a concentrated load lang. Yan. So ito yung magiging figure ng ating shear. So kung saan yung concentrated load class, dun yung pinaka 0 point ng ating shear. And then dun din yung ating maximum moment ng ating moment diagram. So as you could observe, no, para siyang nakasimangot lang. Ayan, na figure. Ayan. So nag-tick siya dun sa ano, sa taas. Ayan. And then, yun, identify din natin, syempre, of course, yung ating mga degree. So kapag straight lang siya, uniformly, so that's our zero degree. Then kapag nag-ano na siya, nag-diagonal, that's our first degree. Then kapag nag-curve na siya, that's our second degree. So ito class is this already our first degree. Then kapag nag-curve, second degree na siya. Then ito na yung third degree niya. So naintindihan class? Okay. So ito naman, yung nasa baba, for example, yung ating uniformly distributed load is nasa baba. So, usually, na-analyze natin to sa mga, sa mga footings. Siyempre, meron tayong what we call the bearing load, pataas. Yan. So, that's why ang magiging figure niya is parang pagano. Say, we have a support dito. Plus, ganyan magiging figure. So, naintindihan class? So, let's proceed na sa ating next situation. So, I'm a bit, slow ba class sa ating facing, ng ating problems. Okay lang, tama lang. Okay. So, let's proceed na sa ating problem. So, we have here situation number 4.3. So, the simple beam ABC is subjected to a triangular load of max intensity of 180 kilonewton per meter. So, we have here a triangular load from point A to C. So we're going to determine the max shear, determine the location of maximum moment, and determine the maximum moment. So for our solution, let's solve first yung ating mga triangular loads. Yeah, and then we already defined then class yung ating mga distances. So of course, class, kapag nag-moment tayo ng mga uniform or triangular load, we need to determine first class yung ating centroids. And then yung value ng ating V1 dito, and then our value. So we know class na given tayo ng 180 kilonewton meter. So first, we have to identify our R1 and R2. So by summation of moment A is equals to 0. Yan. So we have 7 R2 is equals to W1 times 4 plus V2 times 6.33. So from point A, natin, so meron tayo ditong V1, then V2. So we already know, class, no, ano yung mga distances niya. So paano ba nakuha tong 4? So remember, class, kapag nasa toe, kaya ng ating triangle, that's the 2/3 2 over 3 ng ating span. So, let's compute that. Yeah. So, 2 over 3 times our L. So, ano yung buong figure, buong ano nito? Span ng ating first triangle lower load. That's 6 meters. Kaya meron tayong 4. Yan. Then, pura dito naman, para nakuha yung 6.33. That's the first, di ba? Ito yung ina-analyze natin. That's the hill. So, kapag hill, kapag ina-analyze natin from point B to the center of our triangular load, that's the 1/3 ng ating L, di ba? So, ang 1/3 ng ating L is 1/3. 1 over 3 times 1 is 1/3 plus yung ating that 1/3. Yeah, plus 6. That's why we have 6.333 meters. Yan. So, meron na tayong mga distances niya. Then, we could now compute for our value W1. So, nakuha natin yung W1. Meron tayo given ng 180 times 6 na span over 2. Dahil triangular load siya. So, we have 540 kilonewton and 90 kilonewton. So, nakuha kung paano nakuha siya. Yung 540 and 90. And then, by summation of moment, sa A, so we have R2 times its distance 7 is equal to 540 times 4 plus 90 times 6.33. Then we get R8 is equal to 390 kilonewton. Yeah. Okay. And then summation of moment. So Y, so we have R1 plus R2 is equal to 540. Low. Ayan. Okay. So medyo nawala ata. Okay. So 540 plus 90 is equal to 240. So that's why ang ating R1 is 240 kilonewton. 240 kilonewton. And then, yun. So from our figure, we could determine the maximum and highest point ng ating moment. Yan. So since it's a triangular load, so compute natin yung area ng triangular load. 1/2 times 6 times 180, that's, and then, mag-start muna tayo sa 240. So 240 class, then minus 1/2 times 6 times 180. We have a negative 300. So, dito yung negative 300 natin. So, at a certain point, nag-zero ang ating shear. So, since ito is pataas, class, so, again, class, kapag pataas tayo ng level is, yun yung time na parang nagiging malungkot tayo. Kaya, we have this figure. So, meron tayong pa-curve. Pasad. And then, yun.
So, from negative 300, minus din natin yung area ng ating next triangular load, which is 180 times 1. Na meron tayong negative 390 plus yung ating reaction force na 300 is equals to 0. Ayan. So, can you see my screen, class? Or naman ba? Hello? Okay. Kita naman ba, class, yung ating screen? Or nadi-disconnect? Then, for the, ano natin, moment diagram, okay, so ang maximum shear natin is negative 390. So, using our equation ng ano to parabola, class. So, natatandaan nyo ba yun, class? Yung equation ng ating parabola. So, that's the y over x. So, ang ating next na kailangan makuha is yung ating x value from point A to point kung saan nag-zero ang ating shear. Okay, so kailangan natin makompute yun. So, using our equation ng ating parabola, that's the y over x is equals to 180 over 6. So, y over x. So, ito yan, class. Ito yung ating x, ito yung naman yung ating y. Para tayo nag-ratio and proportion pala. Para makuha muna natin yung ating x. Yeah. And then, we also have here 6 and 180. So, ratio and proportion muna tayo. Ratio and proportion. Then, y is equals to 30x. And then, we know that our VO is equals to 0. Yan. So, 240 is equals to xy over 2 is equals to 0. Yan. So 240 minus x times ating y is equals to 30 x over 2 is equals to 0. So, ang ating x is equals to 4 meters from A natin. Yeah. And then next, we're going to compute naman yung ating maximum moment. I mean, yung moment natin at 4 meters from A. So, ano daw ang maximum moment natin? So, we have xy over 2 is equals to 4 times 30 times 4 over 2 is equals to 240. So, from ratio and proportion pa rin siya. So, m natin is equals to r1x minus xy over 2 times x over 3. So, m is equals to 240 times x. Yung x natin is equals to 4 minus 240 times 4 over 3. That's why ang ating moment is 640 kilonewton meter. Yan. So, nag-gets ba yan, class? So, nag-ratio and proportion tayo, class, na y over x. So, ating y over x natin is equals to 180 over 6. 180 over 6. Kaya nakuha natin yung y is equals to 30x natin. And then, shear is equals to 0. From shear equals to 0, we have 240 minus xy over 2 is equals to 0. Yeah. And then 240 minus x times 30x over 2 is equals to 0. Kaya meron tayong x is equals to 4 meters from our tree. Yeah. The next situation number 4.4, overhanging beam natin. So let's read the problem. So a beam ABC. So can you read this one? Okay, so we're going to determine the maximum shear, the maximum moment, and the location of the point of inflection from point A. So solution natin, So this is our figure. Meron tayong R1, R2, and a concentrated load, and meron tayong uniform distributed load. Yeah. So let's compute first our R1 and R2. Yeah. So we have 3.2 R2 by summation of moment B is equal to 0. So 3.2 R1 plus 2.4 times 1.6 equals to 12 times 1.6 times 2.4. Then meron tayong R1 na 13.2. And then yun, let's solve for our R2 by summation of moments sa Y, which is R1 plus R2 is equals to 12 times 1.6 plus 2.4. We have R2 is equals to 8.4 kilo. Then we could now draw our yeah our shear and moment diagram. So this is our shear and moment. So start tayo sa R1 which is 13.2 plus area ng ating load is 12 times 1.6. So, meron tayong 13.2 minus pala plus. So minus 12 times 1.6. So we have negative 6. Yan. And then plus yung R2 natin. So anong R2 natin? 8.4. 8.4. Meron tayong 2.4 minus 2.4 mag-equals to 0. Then for our moment, yan. So for a moment, add lang natin yung ating area, which is 13.2 times 1. So paano nakuha yung A is equals to 1.4 class? So pwede natin gamitin yung Gaussian proportion. So 12A so 12A 12A is equals to 13.2. That's why ang ating A dito is 1.1. So identify na natin yung A is equals to 1.1. So pwede din naman class check natin kung same pa rin tayo ng value. So add lang natin 13.2 plus 6 ay let's say 13.2 over 8 na hinanap natin is equals to ano ba yung buo nito? So 13.2 plus 6 19.2 19.2 over ano yung span nito? We have 3.2. So 3.2. So, try solving it. 3.2 times 13.2. 39.2. Oops. Ay, doon lang pala class. Dito lang. 1.6. So this 1.6. 1.6 times 13.2 divided by 90.2. It's 1. So, gets class. So we could not compute for our maximum moment. And So 1/2 times, we have 13.2 times 1.1. That's 7.26 or 7.2. And then, yan. So, compute natin yung ito naman. Itong figure naman na M2 is equals to negative 3.84. So, we have 7.26. So, 7.26 minus 2 times 0.5 times 2 minus 6 times 1.6. Yan, meron tayong so 7.2 minus 2 over 0.5 times 2 minus 6 times 1.6. So that's, oops. Yan. So, na-compute nyo ba, class? So, so 7.26 minus 2 times 0.5 times 2 minus 6 times 1.6. So that's 2.84. So this is 2 plus. 2.84 yan plus ha. So 2.84. Paano, class? So 7.2 minus 1/2. 26 minus 1/2 times 6 times, ilan ba ito? So we have 1.6 minus 1.1 minus our 6 times 1.6. Ay, 3.84 talaga. 3.84 talaga, class. So, negative 3.84. So, this is 3 talaga, class. So, 1/2, disfigured na nga natin. So, minus 1/2 times negative 6, di ba, class? 6 na. So, 6 times, kunin natin yung distance niya. Which is 1.6 minus, dun sa nakuha nating 1.1. So, ito lang kasi yung kailangan natin. So, that's our first shape. Tapos, minus natin yung rectangular shape. Negative 6.1.6. That's why we have negative 3.84 kilonewton. As we could see, class, ang maximum moment natin is our 7.26 kilonewton. Then, sabi doon dito, what is our x? Kung saan nag-zero yung ating moment.
Yan. So as you could see class, so 3.84. So negative 3.84 plus, ang rectangular natin is 3.1. 3.1 no class, so 3.1 times yung 1.6 natin. 3.1. So from negative 6 plus yung R2 natin. R2 natin is 8.4. So 2.4 pala. 2.4. So then 2.4. So negative 3.84 plus 2.4 times 1.6 is equals to 0. Kaya nag-0 tayo sa moment. So let's compute dun sa ating x. Yan. So saan kailan naging x is equals to 2.56? So from our summation of moment, 0. So R1 times x. Ito yung x natin. So yung R1 natin. We define our x as x muna minus 12 times 1.6. So ito, computin natin ito plus yung W natin minus 12 times 1.6 times x minus 1.8. So ang kailangan natin is yung gitna niya. So, ang gitna niya is 0.8. So kaya naging x minus 0.8. Yeah. So we already know what is our R1. Yan. So let's compute our x. So 13.2x minus 19.2x plus 15.36 is equals to 0. Then we could shift solve. Yan. So our x is 2.56 meters from our A. So from our A. Okay. So let's take a break muna. Okay, at least 5 minutes. And we will now proceed for our um, last sample. Okay. So let's proceed now with situation number 4.5, which is a steel beam ABC is simply supported at A and B and has an overhang BC. BC is equals to 1.5 meters. Nag-overhang na pala tayo. Ayan. So this is our second situation na overhang. So the B supports a uniform load of 3.5 kilonewton meter over its entire length of 4.5. Ayan. And then meron tayong given na allowable bending stress of steel is 60 MPa. So we're going to determine the max shear of the beam, max moment of the beam, and the width beam of the rectangular section having a total depth of 2b. So meron tayong given na allowable bending stress. Then meron tayong, kailangan natin ma-determine yung required na base ng ating beam. So this is our figure. Meron tayong reaction so R1 and R2. So we compute it first. The summation of moment B is equals to 0. And so 3R1 plus 3.5 times 1.5 times 1.5 over 2. Then we could arrive with 3.94 kilonewton. That's our R1. Then our R2. So summation of moments sa Y is R1 plus R2 is equal to 3.5 times 4.5. That's why we have R2 is equal to 11.81 kilonewton. Yeah. Then let's draw our shear and moment diagram. So meron tayong R1 na 3.94 minus our 3.5 times, ano muna natin kung ano yung span, which is 3 times 3. Okay. Okay, right? So, kumpitin muna natin nga yung ito. Yung 3.5 kilonewton. So that's 3.5 times 3. Meron tayong 10.5. I think, ano pala? Rectangular pala. So, 3.94 minus 3.5. That's negative 6.56. And then, plus 11.81. Plus natin siya. Kaya meron tayong 5.24 minus 3.5 ulit times 1.5. Kaya magiging 0. Then, let's compute yung ating... So, as we can see, class, ang pinaka-highest point natin dito is yung ating negative 6.56 kilonewton. Then for the maximum moment, yan. So, 1/2 times 3.94 times our x. So, we have to determine the x. Pero, pwede rin naman hindi na. Ay, hindi. Kailangan ma-determine yung x. So, by ratio and proportion, we could solve for our x. No? That's why ang ating x is 1.13. So, ratio and proportion lang yan, class. So, ang ating x is 1.13 meters. Yeah, 1.13 yan. So, yeah. So, 1/2 times 3.94 times 1.13. So, we have 2.23 minus 1/2 ulit times 6.56. 6.56 times 3 minus x, 1.3. So, meron tayo negative 3.9. Then, plus, para maging 0, 1/2 times 5.25 times 1.5. Meron tayong 0. Shear moment. So, ang maximum shear na moment natin is negative 3.9 kilonewton. So, since meron tayong maximum shear moment, yan, using our formula for the bending stress, so naalala niyo po ba ito, class? Which is the sigma is equal to 6m over bd squared for a rectangular shape beam natin. So, we have to determine what is our base dimension. So, given tayo ng allowable stress na 60 meter per second, megapascal is equals to 6 times m. Ang nakakuha nating maximum moment is 3.9 times 10 raised to 6 over b. And then, ang d daw natin is twice nung ating base square. Then, by computation, we could get for our b is equals to 4.46 millimeter. So, 4.6 millimeters. Millimeters. 4.6. Hindi, 46 lang pala. So, 46. So, ibig sabihin ang ating depth is 92. So, ating depth is 92 millimeters. So, any question pa, class? Yan. So, I hope na you recall yung mga